This is Algebra Lesson 8-7, Factoring Special Cases. Let's factor the following trinomials. Well, let's factor x squared plus 6x plus 9. So since there's no leading coefficient here, we need a product of 9 with a sum of 6. So we need two numbers that multiply together to get 9 and add together to get 6. Okay, I know that happens to be 3 times 3 because 3 times 3 is 9 and 3 plus 3 is 6. So this would factor to x plus 3 times x plus 3. Let's take a look at letter B here. I need m squared plus 12m plus 36. So I need a product of 36 with a sum of 12. Well, 6 times 6 is 36, and 6 plus 6 equals 12. So this would be m plus 6 times m plus 6. So it would factor to m plus 6 times m plus 6, or m plus 6 quantity squared. And the last one here, k squared plus 10k plus 25. I need a product of 25 and a sum of 10. Two numbers that multiply together to get 25, but add together to get 10 would be 5 times 5. So this would be k plus 5 times k plus 5. Well, if I look at this, I can notice a little pattern here. Because I'm looking at this going, wait, back in 8-4, we learned how to multiply a binomial, that was a square, like x plus 3 times x plus 3. So in this first problem here, in letter A, this could be rewritten as x plus 3 quantity squared. Just like letter B could be rewritten as m plus 6 quantity squared, and letter C could be rewritten as k plus 5 quantity squared. So you can factor some trinomials by reversing the rules for multiplying special case binomials that we learned back in 8-4. We learned that we found the square of a binomial. If we had a plus b quantity squared, otherwise known as a plus b times a plus b, that would multiply out to be a squared plus 2ab plus b squared. And a minus b quantity squared multiplies times a minus b times a minus b, multiplied out to be a squared minus 2ab plus b squared. Now, any trinomial of the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, is what we call a perfect square trinomial. And you can factor a perfect square trinomial by reversing what we did in 8-4. So a perfect square trinomial algebraically means that a squared plus 2ab plus b squared will factor to a plus b times a plus b, otherwise known as a plus b quantity squared. A squared minus 2ab plus b squared factors to a minus b times a minus b, or a minus b quantity squared. If you can recognize something is a perfect square trinomial, you can use the special cases and you can factor it much faster. So how can you recognize it? Well, we look for certain things. We can recognize a perfect square trinomial. You can factor it much faster than you can if you're just going to be factoring by grouping or factoring in general. So the first thing you want to look for are the first and last terms perfect squares. If the first term is a perfect square and the last term is perfect square, you're partway there. There has to be no minus sign or negative sign in front of a squared or b squared. Can you rewrite the polynomial so that there's no negative sign in front of your first term or your last term? And then the middle term is twice the product of one factor from the first term and one factor from the last term. In other words, it's 2ab or negative 2ab. So let's take a look at some problems and let's see if we can determine whether they are trinomial squares. So number one here, x squared plus 2x plus 1. Is my first term a perfect square? Yes, x squared is a perfect square. Is my last term a perfect square? Yes, 1 is a perfect square. 1 squared is 1. Square root of 1 is 1. So my a term is going to be x and my b term is going to be 1. So I need to know, is my middle term 2 times a times b? So 2 times x times 1 is 2x. Yes, my middle term is 2x. So yes, this is a trinomial square. Okay, let's take a look at number 2. x squared plus 3xy plus y squared. My first term is a perfect square. My last term is a perfect square. Is my middle term one of the factors from my first term and one of my factors from my last term multiplied by 2? No, because my first term is x, my last term is y. If I multiply that by 2, I get 2xy, and I have a 3xy in the middle, so this is not. Okay? The middle term should be 2xy, not 3xy, therefore that is not a trinomial square. Let's look at number 3. 81x squared plus 36xy plus 4y squared. Well, is 81x squared a perfect square? Yes. My a term would be 9x. Is 4y squared a perfect square? Yes. My b term would be the square root of 4 is 2. Square root of y squared is y. Is my middle term 2 times 9x times 2y? 2 times 9x times 2y. Well, 9 times 2 is 18. 18 times 2 is 36. 36xy. Yes, my middle term is 36xy, so yes, this is a perfect square trinomial, or a trinomial square. Okay, let's look at the last two. Number 4. A squared plus 2a minus 1. Is my first term a perfect square? Yes. Is my last term a perfect square? Yes. Are there any minus signs between my first term and before my first term or my last term? Uh-oh. There's a negative sign right here, which means this is no longer a trinomial square because it has that minus sign. So this one is not a trinomial square. And number 5, 4x squared plus 20x plus 25. Okay, my a term would be 2x, my b term would be 5. So my middle term should be 2x times 2 times 5, which would be 20x. Oops, 20x. I almost wrote down 10x. And my middle term is indeed 20x. So yes, this is a trinomial square, or a perfect square trinomial. Once you can recognize something as being a trinomial square or a perfect square trinomial, they are much, much easier to factor. You simply need to find the square root of the first term, the square root of the last term, and then be able to plug it into the formula based upon where your subtraction sign is. All the signs are taken care of in the formulas. So remember, your two formulas are a squared plus 2ab plus b squared factors to a plus b quantities squared, and a squared minus 2ab plus b squared factors to a minus b quantity squared. So if I look at this number 6, okay, my first term is a perfect square, my last term is a perfect square, my middle term is 2 times the first and the last. So first thing I need to do is I need to figure out what my a term is. My a term is the square root of x squared, which is x. My b term is the square root of 1, which is 1. I'm going to use the first formula because all my signs are positive. So that would be the first formula up here that I have. I'll number these 1 and 2. So the first formula has all my signs being positive. So this will factor to an a, which is x, plus b, which is 1, quantity squared. And you're done. Now you can still factor this product and sum. You can still factor all of these product and sum. It'll just take you a little longer. So if you can recognize something as being a perfect square trinomial, it will speed up your factoring process quite a bit, which is why you want to be able to see if you can recognize them. Let's take a look at number 7. All right, we need my a term would be the square root of n squared, which is n. My b term is going to be the square root of 64, which is 8. Is my middle term 2 times 8 times n, or the opposite of it? 8 times 2 is 16 times 2 is n. Yep, it's negative 16n, so this works. I'm going to use formula number 2 because I have a negative sign right here, and the second formula has the negative sign right there. Same spot. So this is going to be n minus 8 quantity squared. Signs are taken care of in the formula. Number 8. The square root of t squared is t. The square root of 49 is 7. My middle term is 2 times 7 times t, or the opposite of it. So this is a perfect square trinomial. All right, so my a term is going to be t. My b term is going to be 7. Since it's a minus, I'm going to use formula number 2. So this is going to be t minus 7 quantity squared. It just speeds up the process. Just like the special products sped up your being able to multiply, the special factorings, the perfect square trinomial, and is going to speed up your factoring as well. All right, let's take a look at number 9 here. 25x squared minus 70x plus 49. All right, so the square root of 25x is 5, 25x squared is 5x. The square root of 49 is 7. 7 times 5 is 35, times 2 is 70, so this is a perfect square trinomial. I will use the second formula again, which is the minus formula. So it's going to be the a term, 5x, minus the b term, 7, quantity squared. Look at number 10. I'm looking at that going, that first term is not a perfect square, and that last term is not a perfect square. But my brain also looks at this and says, is there a greatest common factor? Because if there is a greatest common factor, you should always take it out first. Always, 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 always. So I'm looking at this going, 8 and 4 is 12, that's divisible by 3. 1 plus 2 is 3, that's divisible by 3. 7 and 5 is 12, that's divisible by 3. Everything's divisible by 3. So I have a greatest common factor of 3. So I'm going to take that out. 48 divided by 3 is 16, so that leaves me with 16m squared. 120 divided by 3 is 40, so that leaves me with 40mn. 75 divided by 3 is 25, so that leaves me with 25n squared. Now my first term's a perfect square and my last term's a perfect square. Square root of 16 is 4, and the square root of 25 is 5. And 4 times 5 is 20, times 2 is 40, so that works. So my a term here is going to be the square root of 16m squared, which is going to be 4m. My b term is going to be the square root of 25n squared, which is going to be 5n. So I'm going to have 4m plus 5n, because everything's added, quantity squared, and then don't forget the greatest common factor that we took out way up here. We need to bring that back down here. So we have 3 times the quantity 4m plus 5n quantity squared. Number 11. 2x squared plus 12x plus 18. I'm looking at that going, oh, there's a greatest common factor of 2 there. So greatest common factor is 2. If I divide everything by 2, I am left with x squared plus 6x plus 9. Now my first term is a perfect square, and my last term is a perfect square. So that fits into the perfect square trinomial. So that's going to be the square root. My a term is x, my b term is 3. So I will have x plus 3 quantity squared. And don't forget, we had to take out that 2, so don't forget the greatest common factor of 2 that comes in front of that x plus 3 quantity squared. Okay, now recall from lesson 8-4 that we also had a special product as a product of the difference in a sum of 2 numbers. Okay, so a plus b times a minus b would ended up to be a squared minus b squared. So a squared minus b squared is the difference of squares, difference of 2 squares, and it will factor to a plus b times a minus b. So for a binomial to be the difference of 2 squares, 2 conditions must be true. There must be 2 terms, both of which are squares, like 4x squared, 9x squared, 81p squared, 36, and there must be a minus sign between them. And that's it. 2 terms with a minus sign between them. If you get an a squared minus b squared, it will always factor to a plus b times a minus b. So again, you're going to figure out what the square root of each one of your first and last term is, and then plug it in the formula. So if I have x squared minus 36, well, x squared is a perfect square, 36 is a perfect square, therefore, and there's a minus sign between them, and there's only 2 terms. So this is the difference of 2 squares. So my a term is going to be x, and my b term is going to be the square root of 36, which is 6. It's not the square root of negative 36. Okay, the sign is taken care of in the formula. So all we need to do is take the square root of the first term and take the square root of the second term, and then make sure we put 1 as a positive, x plus 6, and 1 as a minus, x minus 6. That's the only way you can get those middle terms to cancel out. And it doesn't matter which parenthesis comes first. You can do the minus before the plus or the plus before the minus. All right, number 13, we have 2 terms. Both are perfect squares, and there's a minus sign between them. So my a term is going to be m, My b term is the square root of 100, which is 10. So I'm going to do m plus 10 times m minus 10. Now we can still do these by factoring product and sum, but it's just much, much faster if you can recognize right off the bat that these are difference of squares. Right? Because what we do is we do a product of a negative 100 and a sum of 0. Okay? Which is why there's no middle term, is because your bx term is 0. Number 14, p squared minus 49. Well, my a term is p. My b term is 7, because the square root of 49 is 7. So we will have p plus 7 times p minus 7. As you can clearly see, these are really quick to factor if you can recognize them right away. 15, a little bit different. My first term, 4w squared. Square root of 4w squared is 2w, so my a term is 2w. My b term is the square root of 49, which is 7. So you'll have 2w plus 7 times 2w minus 7. And we are done. Number 16. If I look at 16, I'm like, well, the first term is not a square. The last term is not a square, but there's a minus sign between them. But I also can recognize right away I have a greatest common factor. So I'm going to take the greatest common factor out, which happens to be 5. Right. So if I take that greatest common factor of 5 out of that, I am going to get 5, parentheses, 1 minus 4y to the 6th. And you're like, okay, the first term, 1 is a perfect square, 4 is a perfect square. Is y to the 6th a perfect square? All you have to do to determine if a variable is a perfect square is it divisible by 2 evenly? 6 is divisible by 2, so yes, it's a perfect square. All you're going to do is always divide it by 2. So my a term is going to be 1, because the square root of 1 is 1. My b term is going to be the square root of 4y to the 6th, which is 2y to the 3rd. The square root of 4 is 2, and y to the 6th divided by 2 is y to the 3rd. So I will have 1 plus 2y to the 3rd times 1 minus 2y to the 3rd. But don't forget we took out a greatest common factor, so we have to put that 5 back into this factorization. So there we go. Now number 17 is a little bit interesting. Okay, I'm looking at this going, oh, okay, this is an interesting one. 81x to the 4th minus 1. You might look at it and go, oh yeah, perfect square. 81 is the square root of 81 is 9, the square root of 1 is 1, which is true. So my a term is going to be 9. Since it's an x to the 4th, it's going to have to be x squared, because 2 divided by 2 is 4. And my b term is going to be 1. So I will have a 9x squared plus 1 times a 9x squared minus 1. And this is where a lot of people stop. And that would be a problem, because 9x squared plus 1 is perfectly fine. But 9x squared minus 1 is still a perfect square. Right? 9's a perfect square, 1's a perfect square. There's a minus sign between them. So this second one, this second binomial here will factor again. The a term for that one is going to be 3x, and your b term is going to be 1. So 9x squared minus 1 will factor to 3x plus 1 times 3x minus 1. So we had the 9x squared plus 1. We have to put that back in there, because that was my first term that does not factor again because it's a sum. But that second binomial factored a second time. So you have to be really careful with that, because that will happen periodically, that you'll get something and you'll be factoring it down, and it will factor even further, and you won't recognize it factors further. Okay, now we're going to do some problems that we've done a little bit before, which is you have to take out a common factor first, because none of these are perfect squares if I look at them. Nope, not a close. All right, now these could be any of the special products, special cases we just went through today. They could be a trinomial square, or it could be the difference of binomials. So, difference of squares. So if I look at the first one, 18, 12t squared minus 48. Greatest common factor looks like it's 12. If I take a 12 out of this, I'm going to get t squared minus 4. Well, t squared minus 4 does factor again because that's a perfect difference of squares. So this would factor to t plus 2 times t minus 2. And of course, not t minus 12, t minus 2. And we did take that 12 out to begin with, so we need to make sure we put that in front of the factorization. Because we always want to factor completely. If something factors even more, you have to factor it till it cannot factor again. That's really important. Always factor until you cannot factor anymore. Number 19, 12x squared plus 12x plus 3. Greatest common factor here would be 3. So if I take a 3 out, I get 4x squared plus 3x. No, 4x. I'm dividing by 4 instead of dividing by 3, so that's 4x plus 1. My first term is a perfect square. My last term is a perfect square. The square root of 4x squared is 2x. The square root of 1 is 1. 2x times 1 times 2 is 4x. So this is a trinomial square. So my a term is 2x, and my b term is 1. So I will have 2x plus 1 quantity squared. That is the weirdest looking x I've ever made. Let's clean that up a little bit. There we go. 2x plus 1 quantity squared. Don't forget we took it a GCF out, so we have to put that back in there. So we have 3 parentheses 2x plus 1 quantity squared. Or you could write it as 3 parentheses 2x plus 1 times 2x plus 1. Number 20, 32x squared minus 50y squared. I'm thinking GCF of 2 because they're both even. So if I take a 2 out of 32x squared, I am left with 16x squared. If I divide 50y squared by 2, I get 25y squared. Now I have the difference of 2 squares because 16x squared is a perfect square, 25y squared is a perfect square, and there's a minus sign between them. So my a term is 4x and my b term is 5y. So I will have 4x plus 5y times 4x minus 5y. And don't forget I took out a GCF, so that 2 has to come way down here. That's going to be the biggest nemesis people have, is they'll forget to remember to put that 2, the greatest common factor, in front of their factorization. Highlight it, circle it, do something so that you remember to add that into your final answer. So that's factoring by special cases. As you can clearly see, if you know your special products and your special formulas, you will speed up your factoring quite a bit. Closure question. What special cases did you learn to factor in this lesson, and give an example of each? So name them and then just give me an example of them. What special cases did we learn, and give an example of each?